A Venn diagram is a diagram where the operation can be represented using diagrammatically. So union of set means, suppose you have two sets, set A and set B. Writing all the elements or listing all the elements from A as well as B is nothing but union of set. Union of set and its subset is always set A itself. So when you have any subset of the given set, then their union is equal to the set A. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So today we'll start with the session 4 of the chapter set. Before that, we'll recall what are the topics we have learned in our session 3. So in our previous session, we have learnt about subsets of sets, how we say a set is a subset of another set, also about the proper subsets and superset. Whenever you say A is a subset of B, then A is called proper subset if and only if A is not equal to B, and B is called as superset of A. Also, we have learned how to write subsets of the real numbers in the interval form, where any intervals can be written in the form of A, B, A, B, A, B or A, B, where closed interval represents including the given numbers and open intervals or open brackets represent excluding the given real number, and how to convert into interval form to set builder form or set builder form to interval form. And we have learnt about power set. So what do you mean by power set? A power set of set A is denoted by A, where you will write all the subsets of A. So all subsets of A is written. Any power set will have always empty and set A itself as their element, and the other elements can be a singleton sets or a pair of 2 elements or a pair of 3 elements. And the number of elements in the power set is given by the formula, that is number of elements in a power set is given by 2 power m, where m represents the number of elements in the set A. And finally, we come across a universal set. A universal set is nothing but a parental set, or where all other subsets can be derived, or it can be taken as a main set for all the problems. As we come across operations in mathematics, we have operations in sets also. So today we are basically discussing 2 types of operation. One is union of sets and another one is intersection of set. Before going to union of sets or intersection of set, let me introduce to a diagram called Venn diagram. A Venn diagram is a diagram where the operation can be represented using diagrammatically. In Venn diagram, always the universal set is represented by a rectangle and all other subsets are represented by circle. So, if you have a universal set as R and if you have a subset as natural number, then universal set R can be represented using a rectangle. So this is your universal set, and A is the set of natural number where it is a subset of real number. Therefore, it is represented using a circle. So here I have taken an example. Let U is equal to numbers from 0 to 10, and we have a set 1, 3, 5, 7, 9, which is a subset. See clearly 1, 3, 5, 7, 9, 1, 3, 5, 7, 9 are in universal set. So we can say A is a subset of U. Since A is a subset of U, I said universal set contains all the elements and A is the subset. So therefore it is written in the circle, and elements in A are written inside the circle, and elements which are not in A, they are in U. Therefore we have written inside the rectangle. This is how we will represent a universal set and its subset using Venn diagram. So the operations of set can also be solved using Venn diagrams. Now we will see what do you mean by union of set. So union of set means, suppose you have two sets, set A and set B. Writing all the elements or listing all the elements from A as well as B is nothing but union of set. So what does union of set says? If A and B are any two set, so contains all the elements of A and all the elements of B. That is, symbolically we write A union B. So we use this symbol to represent the operation union, and the definition can be written as A union B means all the elements from A or B. So you should write all the elements from A and B. So here I have taken an example. Let A is equal to 2, 4, 6, 8 and B is equal to 6, 8, 10, 12. Find A union B. So what do you mean by A union B? All the elements from A as well as B. So write all the elements 2, 4, 6, 8. You have 6, 8 already in A union B. So no need to repeat it. Just remaining numbers 10 and 12. So you have all the elements from A as well as the elements from B. So this is how A union B is written. That is, writing or listing all the elements from A or set B. Next, here we have union of set A and its subset B. Suppose B is a subset of A. Let me take an example. Suppose A is equal to ABC. And B is equal to A and C. Clearly, what is relation between B and A? B is a subset of A. Now write A union B. So A union B means writing all the elements of A as well as B. A, B, C, and A is there, C is there. What is this actually? A. So when you are taking the union of a subset and its set, the subset, so what does the statement say? Union of set and its subset is always set A itself. So when you have any subset of the given set, then their union is equal to the set A. As I said, Venn diagram is to represent the operation of set. This is how we will represent the union of set. So this is your universal set, and A and B are the subsets of any universal set. If A contains some elements and B contains some element, the common elements is written inside the oval here. For example, say A is 1, 2, 3, 4, 5 and B is 2, 4, 6. Now how you are going to write the elements of A and B is, write the common element inside the oval here. So what are the common elements we have? 2 and 4. Observe the circle A, only A. So in A already 2 and 4 is written. The remaining elements are 1, 3 and 5. And in B we have 2 and 4. The remaining elements are 6. So this is how when you are shading, so since the complete shading of the circle of both set A and set B represents the union of the two sets. We'll see one more example. So we have set A is equal to AEIOU, B as AIU. Show that A union B is equal to A. When is this possible? This is possible only when B is a subset of A. Correct? So you can see AIU is in A. So clearly B is a subset of A. So therefore A union B is A. The union of the set and its subset is A itself. So therefore we can see here B is a subset of A. Therefore A union B is A. Next, As we have properties in basic operation like plus, minus, multiplication and division, we have some properties on union and intersection also. So you're familiar with this word, but let me check with the union and the next with the intersection. So we have a commutative law. What does commutative law says here? A union B is always equal to B union A. Next we have associative law. So the union of three set. So A union B union C is equal to A union B union C. Next we have here empty set. So what happens when you are taking union of an empty set with other set? It is always A. I'll give you an example. If A is a set containing 1, 2, 3 and B is your empty set, no elements in set B. What does A union B represents? Writing all the elements. So here you don't have any elements. So no need to write. What is this 1, 2, 3? It is again A. That is what here the law of identity element. The here phi is considered as the identity element in the universal set U. So therefore A union empty set is A and A union A is again A. So which is idempotent law. When you are taking union of the same set, you will get the same set. Next, law of universal. So that is when you are taking union of the universal set along with its subset. As I said, the union of the set and its subset. We know that A is a subset of U. So therefore, you should get U again. Next, intersection of set. As we learned previously, union of sets means listing all the elements from A or B. Intersection of sets means listing only the common elements of A and B. So that is, if two sets A and B are there, then we are taking elements which belongs to both A and B. That is common elements. So we are writing only the common elements which are present in A as well as B. So it is denoted by this symbol, and the definition of A intersection B can be written as like this: all the elements of X where X belongs to A and X belongs to B. There the condition is whether you have in A or B. Just write it, all the elements from A and B. But here, elements should be both in A as well as B. That is, you are going to write only the common elements in both A and B. I'll take an example here. Let A is equal to 2, 4, 6, 8 and B is equal to 6, 8, 10, 12. Find A intersection B. So what is your A intersection B here? What I said, you are going to write only the elements which are present in both sets. So what are the elements here? So 6 and 8. 6 and 8. What in case if A union B is given? So A union B, write all the elements from A and B. That is 2, 4, 6, 8, 10, 12. So this is the difference between your intersection and union. Intersection, writing the common element. Union, writing all the elements from A and B. Next, I am taking one more example. A is given from 1 to 10, B is 2, 3, 5, 7. Find A intersection B and show that A intersection B is equal to B. So when this is possible, we'll see it. But clearly we can see 2, 3, 5, 7. 2, 3, 5, 7 are in A. So clearly what we can write? B is a subset of A. B is a subset of A. So the intersection of a set and its subset is always the given set. So let me check A intersection B. Let me write only the common elements which are in A as well as B. We have 2, 3, 5, 7 in A also, 2, 3, 5, 7 in B also. What is this? This set is your B. So A intersection B is B and we have proved it. So this is possible only when B is a subset of A. So therefore note that intersection of set and its subset is set B. That is, when you have any subset of A, then its intersection is always the smaller set or it's a subset. Whereas in case of union, if B is a subset of A, then A union B is A, the larger set. Whereas when it comes to intersection, A intersection B is the smaller set or the subset. Next, the intersection of any two sets can be represented by the Venn diagram in this way. Here how? Only the middle part is shaded. Why? Because only the common elements is the answer for the intersection. So where we will find the common element? Inside this oval. So therefore, this is how we will represent an intersection of a set using Venn diagram. Next, one more property, disjoint set. What does this disjoint set means? If A intersection B is empty, I'll take an example. Let me take A is equal to ABC and B is equal to EIO. What is the intersection of these two? Do you find any common elements here? No. So therefore, this is an empty set. So whenever you are intersecting any two set and you will get the answer as empty, then they are called as disjoint sets. So disjoint sets mean their intersection is empty. Whenever the intersection of two sets is empty, we call it as disjoint sets. Next, we have given here an example. A is 2468, B is 1357. What is A intersection B? Here it is empty because you are not finding any common element. So therefore, what we can conclude here, A and B are disjoint. Why? Because you are not finding any common elements in A as well as B. Next, we have some properties for intersection also, as in case of union. Again, we come across a commutative law. What does it state? A intersection B must be equal to B intersection A. Next, we come across associative law. Again, A intersection B intersection C is equal to A intersection B intersection C. And law of phi and u. When you are intersecting with an empty set means no elements. In A, let me take, you have two elements. Here, this is nothing but you are not having any element. What is the intersection of these two? Do you find any common elements there? No. So therefore, your answer is empty again. So therefore, phi intersection A is empty. Next, U intersection is A. Why? A is contained in A. Correct? A is a subset of U. So whenever A is a subset of U, their intersection is A itself. This is what law of phi and U says. Next we have idempotent law. Again, union of the same set is the same set and intersection of the same set is again the same set. Next we have one more law called distributive law. So what does this distributive law says? Where here we are operating both intersection and union at a time. This is called as intersection distributes over U. How this is defined? A intersection B union C can be written as A intersection B union A intersection C. This is distributive law. You can verify it by taking examples also. Next, here is a question given. Find the union of each of the following sets. Question 1. A, x is a natural number and multiple of 3. What are the natural numbers which are multiple of 3? So it starts from 3 only. And it is infinite. 3, 6, 9, 12, 15, etc. We have number of multiples of 3. So therefore, we'll use dots there which defines infinite. Next, x is a natural number less than 6. So what are the natural numbers less than 6? 1, 2, 3, 5. Clearly they have said less than 6, so we'll stop with 5. What is A union B here? So what is A union B here? You have to write the elements of A as well as elements of B. So let me start here. 1, 2, 3, next 5, 6, 9, 12, 15 and it goes with the multiples of 3. So here union is again infinite, but you should include 1, 2, 5, 3 in between them. Next we have set A is equal to 1, 2, 3 and set B is equal to empty. What does the law of 5 says in the union? What happens when you make a union with an empty set? It is again what? A. So therefore, when you are taking union of an empty set and the set, the answer is again A. So therefore, here also your answer will be A. Next, here's a question given. Let A is A comma B and B is ABC. A is a subset of B. What is A union B? These type of questions may asked for 2 marks. So very simple question, logical question. You can clearly observe here A is a subset of B because all the elements of A are in B. So when A is a subset of B, what is A union B? It is B, the larger set. Whenever you are taking the union of the set and its subset, the answer will be the larger set. So here B is the larger and A is the subset. Therefore, your union will be B. Again, you can verify it. Again, the same question is repeated. If A and B are 2 sets such that A is a subset of B, what is A union B? If A is a subset of B, what is A union B? Your answer is B. You can verify taking examples on your own. Next question, we'll take A is 1, 2, 3, 4, B is 3, 4, 5, 6, C is 5, 6, 7, 8, D is 7, 8, 9, 10. Find A union B, B union D, A union B union C, B union C union D. What does union mean? Union means writing all the elements from the sets. Now A union B. So I'm writing first one, A union B. So what is A union B? Writing all the elements from A as well as B. So that is 1, 2, 3, 4, 5, 6. Next, what does second question says? B union D. You are taking the union of B as well as D. So B is 3, 4, 5, 6. D is 7, 8, 9, 10. Next, third one. A union B union C. Writing all the elements from A, B, C. Just write all the elements from A, B, C. 1, 2, 3, 4, 5, 6, 7, 8. Next, B union C union D. So take all the elements from B, C, D. So what is B? 3, 4, 5, 6. C is 5, 6, 7, 8. And what is D? 7, 8, 9, 10. So this is how we will write the union of the sets. Next, find the intersection of each pair of sets. The same question is taken as union. X is a natural number and multiple of 3. Again, A is what? 3, 6, 9, 12, 15, etc. So here B is 1, 2, 3, 4, 5. So what is A intersection B? Intersection represents only the common elements. So what are the common elements here? Only the number 3. So therefore your A intersection B is 3. Next we have A as 1, 2, 3, B as empty. What does law of 5 states? Whenever you are intersecting with an empty set, your answer is empty because there is no common elements in the two sets. So therefore your answer here A intersection B is empty. Next we have the sets which are given in the set builder form. We'll just see what are these now. X is a natural number. Natural number means A can have all the numbers from 1, 2, 3, etc. What about B here? It is even natural number. Even natural number means the elements 2, 4, 6, etc. Next here, odd natural number. Odd natural numbers means 1, 3, 5, etc. Prime numbers. So prime numbers are 2, 3, 5, 7, 11, etc. Now we'll see these operations on intersection. What is A intersection B? Clearly here B is a subset of A, correct? All the even natural numbers are contained in natural numbers. So whenever you are intersecting the subset and the set, what is your answer? Your answer, that is A intersection B, is B again. That is the only common elements you will get from these two sets is 2, 4, 6 again. What does 2, 4, 6 represents? B. Next, C. All odd natural numbers are in A. So therefore, your answer is C here. Why? Because C is a subset of A. So C is a subset of A means all the elements in C are in A. Therefore, your intersection is C. A intersection D is again D because all the prime numbers are natural numbers because D is a subset of A. Next, B intersection C. We take B and C. In B, you have only even numbers. In C, you have only odd numbers. Do you find any common elements? No. So, therefore, empty. Next, B and D. B is all odd natural numbers. D is all prime number. So, except 2. In D, all others are odd natural numbers. So, therefore, all odd natural numbers except 2 are present in odd natural number. Next, we have B intersection D. So, B is even natural number and D is prime numbers. The only number which are common in both the set is 2. That is even prime number. So, here you have only 2. Next, we come C and D. So, C is odd natural numbers. Here you have odd prime numbers with one even prime. But 2 is not in the 2 sets. So, C intersection D is only 3, 5, 7, 11, etc. You cannot write 9 because 9 is not a prime. But 9 is odd. But 9 is not a prime. So, the answer here is only odd prime numbers. Odd prime numbers. Next, which of the following pairs of sets are disjoint? What did I say? It must be a disjoint. Their intersection must be empty. So, here we have 1, 2, 3, 4. X is a natural number. What does this indicate? You are going to include 4 and 6. So, therefore, this set contains 4, 5 and 6. So, here you have 1, 2, 3, 4. What about their intersection? You are getting 4 in common. So, this is not empty. So, this is not disjoint. Next, we have A, E, I, O, U, C, D, E, F. So, do you find any common element? Yes. So, you are getting E as a common element. So, therefore, this is not disjoint. Next, even integer, odd integer. As we did previous problem, even numbers and odd numbers. When you intersect them, your answer is empty. So, yes, they are disjoint. So, therefore, whenever we say sets are disjoint, what does this mean? Their intersection is empty. Their intersection is empty. Their intersection is empty. Next, State whether each of the following statement is true or false. Justify your answer. What is my first question? 2, 3, 4, 5, 3, 6 or disjoint set. False. Why? If it is disjoint, their intersection must be empty. But here 3 is common in both. So therefore this is false. Next, A, E, I, O, U, A, B, C, D, disjoint. False again because we have a common element A there. 2, 6, 10, 14, 3, 7, 11, 15. Disjoint. Yes, because no elements are in common. Their intersection is empty. Next, 2, 6, 10, 3, 7, 11. Yes, they are disjoint because no elements are in common. So this is all about the union and intersection of set. So whenever it comes for the union, you have to write all the elements either from A or from B. And when it comes to the intersection, you are writing only the common elements which are present in both the set. And disjoint sets are one extreme case where the intersection becomes empty. So I hope you understood today's class very well. So we'll meet you in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.